So yeah, I work for ThoughtWorks. I'm a developer with ThoughtWorks, and ThoughtWorks is a consultancy company. We have lots of offices around the world, and I am based in Sydney, Australia. That's why I have such a Russian accent. Everyone speaks like that in Australia. I'm currently engaged with this client, Commonwealth Bank, and the whole thing which I'm going to talk about today is connected to the experience of working at this company. They have a very strong engineering team, and I learned quite a lot about functional programming and working with Scala with these people. So today I'm going to talk about property-based testing. And well, in the last couple of years, I started to love functional programming. I just love all the concepts. And I love that many mainstream technologies, they started to adopt some really good ideas from functional programming, like how we deal with nulls and exceptions with some either and option monad. We have monadic compositions with collection pipelines in JavaScript and in Ruby. We have functions as arguments and lots of other really good things. But when I started to work with Scala, one of the most favorite thing for me was actually like property-based testing. And unfortunately, I haven't actually seen property-based testing used in mainstream languages like Java or JavaScript or Ruby. And I don't understand why, because I think it's like the most underappreciated practice from functional programming, which people don't actually think about in mainstream technologies for some reason. And in the last couple of months, I've been traveling a lot in Europe, and I've attended lots of conferences, and I heard so many talks about property-based testing. So I'm doing another one, and I think it's just like too many talks about this thing is just barely enough. So how many people actually use property-based testing? Well, this talk is going to be quite like introductory talk about the concept itself and some patterns and practices we used in my team. So I'll just start from like what is property-based testing. So let's say we have this function sum, which accepts two arguments, integers x and y, and it gives you the result of sum of these numbers. So the opposite of property-based testing is well-known example-based testing. In example-based testing, you would write something like that. You would be like, well, I want to validate that with the given zeros, the result of sum will be 0. And if I give 0 and 1, the result will be 1. If I give 2 and 2, the result will be 4. And as you can see, the input for these functions was invented by me. So I sat down, I thought about the use cases. I thought that, well, these are the use cases we want to test. And there they are, right? So in property-based testing, I would, instead of supplying examples, I would provide the type of the input. I would say, well, for all x and y's of type integer, I want my sum to produce the sum of element x plus y. All right. So as you can see, like basically, I'm saying that sum equals x plus y. Well, imagine this is alternative implementation of sum, not the actual x plus y. All right. So let's have a look at another very important function from math, square root, right? The first thing you like think about square root is like the square root from x multiplied by x equals x, right? And this is my property, this is my statement, and I want it to be truth, right? I think it's fair enough, and at the same time, I haven't thought about a lot about like edge cases. I haven't thought if it's going to actually work or not, so I'm just going to run it, and well, I got some errors, right? So basically, my test failed after 0 passed test. Basically, none of the test passed. And the first argument it failed with was negative number. Well, obviously, because like the square root from something is not going to be negative number. So it's okay. I can fix it. I can change my statement about about that. And I can say that, okay, the square root from something equals absolute value of this, right? And then I can run test again. And it fails again. But you see, it's actually a different error, the different value it fails on, which gives me different kind of idea of like, well, something is wrong, still wrong, but the previous error is fixed. So you see there are two lines. Is it working? Okay. So there is original one and there is argument _0, right? So the original one is the big one, right? So this value was the first one which made my test fail. So how it works is Scala Check generates these values, and it finds the first value which makes your test fail, and then it stops. It stops generating anything, and it starts shrinking. So the shrinking concept, what it does, it actually literally shrink your input. Basically, it is trying to find the minimum value which still fails your test, right? So here, that was the original value, and that is the shrinked value. So Scala Check found for me that this value was the minimum value which failed my test, right? So Scala Check provides some sort of standard instances for generators and shrink as well. So you have like algorithm on how to shrink integer values, and it is provided by Scala Check. So you can that's how it looks like. So you can ask, can you please give me like shrink for integer, and we can try to shrink some integer, right? And it gives you back a stream of values, right? And it looks like that basically. It literally tries to find the minimum value which makes your code failed. That's how it failed again, right? So when it shrinked, it gave me this weird value, 46341, right? And like, what is that? And then you start thinking then, well, the maximum value of integer is this, right? And when you multiply these two magical numbers, it's not going to be int. It's going to be integer overflow. And it's something that you haven't thought about when you made the statement about square root. When you multiply, well, this is a signature of multiplication function, right? It accepts integer, it accepts another integer, and it gives you integer, right? What it actually says, that for any integers, when you multiply them, you're going to get integer back. But in fact, they are lying to you. They're liars, because it's not going to give you integer all the time, and that's what we found out with this property-based testing, right? So we can fix it as well. We can apply condition on the on a generator, right? We can ask Scala Check, can you please give us a generator for integer, like here, normal generator, but could you please also verify that when we multiply those two integers, it has to be defined. And if it's defined, we want this property to hold. And yoo-hoo, it passed, yay. So the next thing is actually very important. It's about validating your generators, right? So it doesn't really matter what you generate. It doesn't really matter if you're using standard generators or your own customized generators of data. It's always a good idea to verify what exactly has been generated for your test. And Scala Check gives you this opportunity. You can collect, you can collect the value, and it will give you a stats on what actually has been generated. And if you have a look here, you can see that 35% of the values were generated, it's -1, then 1 and 0. It's not actually a good distribution of integers I'm expecting from this property-based test. But basically, it says that I only managed to generate 3 values. And I'm not really happy with that. And one of the reasons for that is condition, is because of the condition. So how it works is Scala Check gives you a generator, a standard generator for integer. Then I'm trying to apply a condition asking that multiplication of those two integers has to be defined, right? And how it works is Scala Check just gives up, or Scala Check doesn't actually try to give you a big range of values. It just like gives you a very small range of values. And this is kind of downside, which we found out at our project. Also, conditions sometimes, if you add extra things, like let's say I wanna generate an integer value, I want the multiplication of them to be defined, and I also want this value to be more than 0. And if you run this test, you're just gonna get an exception saying, well, I couldn't do that. I just gave up after 67 pass test. Basically, Scala Check couldn't actually generate you the whatever you asked for. And it is all because of these conditions. So basically, the condition for this property is too strict. That's how they say it. I am not sure exactly why it's happening, but that's the case right now. So the alternative of how we can work around this problem is to use our own generators, right? So instead of using arbitrary of integer, you can just provide your own generator saying, okay, can you please give me a generator from minus 40 something till plus 40 something, and giving the custom your own generator. The result of collected data is more satisfactory, right? You see? Yeah, and the test still passed. Yes. Cool. So far, we did a Scala Check property for square root, which is the most important problem in software development. Then we did some shrinking, and we actually know what shrinking is now. I think shrinking is quite interesting concept. I will talk a little bit more about it later and how we actually used it, or to be honest, not used it at our project. Yeah, we played around with restricted and conditioned generator, and created customized generator, and the most important thing, we actually validated the input. So the most important thing about what just happened for me was that I was able to discover edge cases. I was able to discover the fact that square root is a positive number. And I was able to discover about this thing called integer overflow. I didn't have to know that before I actually started testing. And probably those kind of issues, like square of root is a positive number, probably every person should know that. But we're just people, so we're going to forget about it at some point. So yeah, property-based testing for me is all about discovering edge cases instead of inventing them or remembering them. Now I want to talk about Gen. So this is the hugest concept in Scala Check. It's actually the idea of how to create generators, right? So Gen is actually a really cool thing. First of all, it's a monad. And because it's a monad, it's also an applicative. And because it's an applicative, it's also a functor. And because of all of this, you have really nice patterns of usage of this Gen, right? So it works like this. So let's say we ask Scala to give us a standard generator for integers. So you can get samples. And as you can see, it doesn't give you the real values. It gives you a values wrapped inside of option monad. It means that sometimes it will fail to generate your values, right? And we actually saw a good example of that when Scala Check gave up to generate our values, right? So let's say we have a case class, customer, which has name and age. We can use monadic composition to create a generator for customer, because Gen is a monad. And you know what is the best thing about monads? The best thing about monads is you can compose them. So basically, it means we can ask Scala Check to give us standard generators for string and standard generator for integer, and we can just compose them and create a customer. And thanks God, Scala has for comprehension. because that looked just horrible. So this is how like normal kind of generator will look like, right? Here is a little bit more complicated example. So let's say we have a customer with optional insurance, right? So some people have insurance, some people don't have insurance, right? So for the generator to work, we need to provide another generator. So we need to tell Scala Check how to actually generate insurance, right? And here we are using a little bit different pattern for generating, for creating generator for insurance. We are using functor because we're just getting a standard generator for string and we are mapping on it, which is cool. So that's how it would look like with monadic composition again. So here we're not actually creating a new generator, we're just asking Scala Check, could you please find already existed generator for optional insurance? It'll give us to us, right? So there is another pattern of creating generators, applicative, because it's a monad, it's also an applicative, right? So you can do that, right? You can take standard generators for strings, integers, and the generator which we just created for insurance, and you can do applicative composition, and you can create customer like that, right? So what is the difference here? Nothing, it's just syntax. There is no actually difference. It's really up to you. It's like, I think it's a matter of taste here in this particular case. And I'm not sure, like, there are people who like this more, probably because of this. Like, look at how beautiful it is. However, there could be a difference. So the main difference between monadic and applicative composition is that when you compose it as a monad, you can actually compose monads which depend on each other, right? Here we have an example of when we ask Scala Check to generate us insurance, not an optional insurance, just insurance, right? And then we create a new generator which depends on the output of that generator, right? And this can be only done with monadic composition. You can't really do it with this beautiful syntax thing. And actually there is a difference between doing it like this over actually asking Scala Check to give you optional, arbitrary of optional instance. Because of the distribution, what I've noticed is when you create an arbitrary of optional instance of optional something, you're gonna get, I think you're gonna get about 10% of none and 90% of sums. But sometimes you wanna like 50-50, right? And in this case, you're gonna get 50-50. But the main point was just show you that like sometimes there is a reason to use monadic composition. Yeah. And I don't really see any reason to use applicative composition. Maybe I'm wrong. It would be nice to hear any other opinion. Right, and there is this thing called Scala Check Shapeless, which is really nice library. You can just add this library and it will generate all the arbitraries for you. And it also will generate you shrinks. Shrinks is like the kind of algorithms of which will tell Scala Check how to shrink your results, right, when it fails. And you can get the instance of generator just like that. It's very, very easy. The only problem with Scala Check Shapeless is it will just generate you this. So, and it's useful. It's useful. That's how you want to start to write your property-based test. You don't really want to start to write tests by restricting or adding extra conditions on your generators, right? You want to see all the possible inputs, right? And then after you see failures, you want to decide if you want to actually add extra restriction on a generator. So that's why probably it is a good idea. But at the same time, right now in my code, majority of the generators for like complicated models, they are customly created. I just can't use shapeless generated generators. which is probably not a good practice. Probably it's a sign that something is wrong over there. Right. So restricting and reshaping generators, right? So this is, as I said, you will end up doing that anyway. Ideally, of course, you do not want to. And obviously, I think the reasons are quite obvious, right? Let's say if you have a case class person which has like a name of string and age of int, it tells everyone that it's string and int. It tells all the other classes that this customer may contain any integer and any string, right? But once you restrict your generators, you're not testing your application against these types anymore. So basically, you're doing the same as Scala did with multiplication function. You're basically lying to other code about your types. So, all right, so we saw already that you can restrict your generators by adding some sort of conditions at the beginning with this double rocket thing here, right? Or you can actually just create your own generators, right? That's another alternative. What else you can do? You can still you can create your own generators with monadic composition, and if you wanna modify them, you can actually just use copy. Let's say we have this optional insurance, right? Then we want to create a generator without insurance. We just want to, like, all the customers which don't have insurance. Let's say this is our valid input for our test case, right? Then it's really easy. You just get a standard generator and you modify it like that. Right, so generator also provides these two utilities, which is such that and retry until. So such that is just an alias for this double rocket thing, which we already used, right? So basically the downside of such that is that you may receive this gave up after something exception, right? I think the reason is because how it's implemented is basically using the original generator, and then it tries to verify the condition, and if the condition doesn't actually satisfy, it just fails the generation, right? And then you have retry until, and retry until creates a new generator. It gets the first generator, and it asks this generator to generate values again and again until the condition is satisfied, right? Besides that, Gen also provides really nice utilities you can use to create your own generators. You can, let's say, this is quite cool. You can just choose between values. It actually gives you a range for all the numbers. You can also use one-off. One-off is, well, yeah, generating optional values is one thing, but you can also use it for generating enums. Also for string, let's say if your customer for some reason just can't have names containing Chinese symbols, you can use alpha string. You have numeric string, which only has numbers. You can have positive numbers, you can have negative numbers, and there are like loads of other utilities available in Gen, which is quite cool. Yeah, shrinking again, yes. I can. Any questions so far? No? Okay. Maybe later. So shrinking. So shrinking is provided by Scala Check for some standard types like string and integer and tuples. So let's say you want to shrink a hello world string. It's literally gonna try to shrink this string like that, right? So you're gonna get hello world and stuff like that, right? But it's going to get a little bit more complicated for, yeah, this is tuple example also provided. Basically, you're asking Scala Check, can you please shrink tuple of string and int? And yeah, it can. You don't need to do anything for that, right? It gets a little bit more complicated when you have a like your own custom case class, right? Let's say you provided a generator for that, and then you have a property. So here we have optimal proposition with like name and score, and our property, where we're saying that, well, all optimal propositions should have positive score, right? And once you run it, you see we only have one line here. We only have one error saying it failed on optimal proposition with this value, with this score, right? It didn't actually even try to shrink this case class, right? So what you can do, you can provide this shrink for optimal proposition. And you see how much code actually I had to write. And this is just using a composition of standard shrink instances. So I'm using standard shrink for tuple string and int, and I'm just constructing an optimal proposition. So that's how you shrink. So basically, to shrink optimal proposition, you just need to shrink a tuple of string and int. And to be able to do that, I had to write all this weird code. And of course, when I run the test, I would get two values here, right? So I would get original, and I would get the shrinked one. And before that, it was just only one, right? So obviously, I can see the benefit. I can see the benefit of it. So it's easier to see that, okay, it fails on the minimum input of 0, yeah. Right. You can also do shrinking with Scala Check, Shapeless Scala Check. As I said, it provides generators for all the case classes. I mean, it will generate it for you, but it also will generate shrink instances for you as well. But it's not, what I'm trying to say, it's not gonna get so easy if you have restricted generators. If you have a modified generator for optimal proposition, which just generates strings containing alphanumeric characters, which just generates integers in a range of this and this, then your shrink instance is not going to work. So you have to modify your shrink instance as well. And there is no correlation between your generator and shrink. So basically, you modify your generator, and there is nothing to tell you that, hey, you forgot about your shrink instance, actually. And at the end, you're going to end up with some failed test, which will give you like original value and then shrinked value, which doesn't even make sense. So I guess that's one of the reasons we don't really use shrink instances in our project really often. Right. I also want to talk about this thing called testing pyramid. Anyone heard about this? I hope, like, yeah, most of people heard, right? So the idea, it's quite easy. It's basically you write lots of unit tests, not that many integration tests, and like very little end-to-end test, maybe like happy pass, right? So when you think about property-based test, what we were trying to do in our project was, well, obviously to write all the unit tests as property-based tests. But at the same time, we wrote most of the integration tests as property-based tests as well. And I actually think that it's way more beneficial to have integration test as a property-based test, because there are so many moving parts, and I know it's very expensive. It's very expensive to write this kind of test. We spend lots of time of writing them, and basically every time something changed, you're gonna spend lots of time to maintain this test. But at the same time, for some reason, when people write example-based tests on integration level, they just forget about edge cases. So when we write unit tests, we are really good at edge cases. We're gonna test all the zeros and nulls, values and exceptions which are even possible. But on the integration level, for some reason, we just like do happy pass or stuff like that. And it's amazing how many actually edge cases we discovered by doing property-based tests on integration level. Let's say simple things like databases, actually, like generating some entity, inserting into the database, selecting it, and checking that it's the same value. We found lots of bugs like that. Yeah, that's called round trip. And during the work at this project, I found like couple of really useful patterns, and I think round trip is the most amazing one. It's very simple. Basically, let's say you have a string, you reverse it, and then you reverse it back, and you claim that it's the same string. Surprisingly, this pattern covers a lot of test cases in commercial applications. First of all, it's just data transformation. Let's say you have a data transformation which transforms into different shape, and then it transforms back. It's quite easy, right? But another one is JSON. We all probably do JSON converting one object into JSON, right? So here we have a generator for JSON object of a special shape, and then we are claiming that for this generator, if we create an object out of this generator, and then we create a JSON out of this object, we want this JSON to be the same as the one which was generated. Also really useful, and it discovers some weird errors with dates, first of all. Nulls, for example, when you create a JSON object out of empty string, it's going to be null or not presented. So basically, it helps you to achieve some consistency. Another pattern, another usage of this pattern is probably database, the one I already talked about. So you generate an entity, and then you insert this entity in a database. Then you select it back and check if it is there. Another useful pattern is invalid input. So when you generate arbitraries, you don't. Sometimes you forget about invalid data, right? So here, let's say you have a CSV parser, right? And you can have a test which would get an arbitrary of invalid CSV files, and it will just check that, well, it will fail all the time. And I found that having generators which generate invalid input is quite cool. It also helps you discover what's going to happen with your application if it's invalid. Just basically making your application fail safe. There is also a thing in Scala Check where you can generate function. I haven't found the usage in my application for this functionality, but it kind of looks cool. Maybe if, let's say, you have a mock, like a function which you don't care about, and you tend to mock it, maybe you can use a generator for that. So here, let's say we're asking Scala Check, hey, can you please give me a function from int to string? And the cool thing about it is you can provide to this function, well, the same values, and the result will be the same, right? And if you provide different value, the result will be different. Yeah, it's kind of interesting. So Specs2 and Scala Check, that's what we use in our project. That we found it's a very nice combination, I guess. The reason is because we still have example-based tests. We can't really do all the tests to be property-based tests, and Specs2 provides really nice support for that. So yeah. So I'm done with Scala. I want to talk about other languages. Do you have any questions about like what you just heard? Yeah?
How do you prevent your specification test there being a copy of the code you've already written?
Oh, I will talk about it, yeah, but it's a good question. It's a very common problem. So sorry, I can repeat the question. The question is, how do you prevent yourself from re-implementing the same logic in test as was in production code? There was actually a really nice talk by, I don't remember the name of the guy. He was talking at Scala.io. The conference happened like maybe a week ago. And he did talk about it, actually. Yeah, he gave a really nice example on how to deal with this problem. But yeah, there is a tendency when you write a test, a property-based test, there is a tendency to re-implement the logic. For example, you created a function for quick sort, which takes an array of numbers and does quick sort of it, right? And if you think about how would you test it with property-based, you would generate an array of numbers, you would sort it and then you would assert that it's been sorted the same way as your new function, right? So you would have to re-implement sorting, right? But the only difference is you don't have to implement the solution, you just need to implement a solution, right? You don't have to implement the quick sort. And I guess that's one of the things. And another of the things is what we do in our project, we just split our input into different cases. It's hard to explain. I can show you in the example later. Any more questions about Scala? Yeah?
So one of the things that we found is you do this a lot for the round trip JSON,
Mhm.
the example that you gave, but it's really slow. Have you found that that's a problem, or have any way to mitigate that?
We found that it is really slow with like database. We wanted to run our tests on real database because we use Oracle. There is no point to pretend that we're using in-memory database. It kind of loses the point. And it was so slow because we would actually, erase and recreate databases every time we run the test. And we just changed a little bit our patterns of running this test. We would reuse our databases, which is not as clean as you would imagine, but at least we're not sacrificing the quality, because the other alternative would be to change the parameter called run minimum test, right? So by default, it does 100 tests. You could change it to 5. You would sacrifice probably quality a little bit, but it will be fine with the speed. But I don't think I've never noticed it to be slow on like JSON round trips, because it doesn't really involve anything kinda. However, it is really slow on compile time. Like once you have a very big model and lots of generators, it's just impossible to work, especially if you work in IntelliJ IDEA and expect it to help you to like write code. It doesn't, because it's just too busy compiling stuff. Yeah. Any other questions? Yeah? Because I really want to talk about other languages. I have 4 minutes. All right. So the reason I want to talk about other languages is I still want to see property-based testing like as adopted practice in mainstream technologies. And you know what? Pretty much every mainstream language has a Scala Check, has a property-based testing library, Java and Ruby and JavaScript, like anything. So here I'm going to show you some Ruby. I use the library called Ranty. I don't think it matters which library I use, because the library is old, no one supports it, and I'm sure Ruby already created like hundreds of more property-based test libraries. But anyway, so this is another important problem of software development, FizzBuzz. So here in Ruby, it's also quite easy with this library. You could have do something like, I want to define a property of integer and I want to check it. And I expect, if it's divisible by 3 and 5, I want to be FizzBuzz. If it's divisible by 3, I want to be Fizz, and then Buzz, and this. Easy, right? And here is what you were talking about. Basically, I just re-implemented the whole solution, right? It looks exactly the same. So FizzBuzz is not actually a real problem. But it does happen in production. So what I would do in production, I would actually separate this into 3 or 4 different test cases. 1, 2, and 3, and 4, and then you wouldn't have to actually re-implement it. And then you would provide different generators for those 3 inputs, right? So the first generator would be all the numbers which are divisible by this, second, and etc. like that. And this is Rust. This is another language I want to talk about. I don't really know Rust, but there is a property-based testing library in Rust as well. I'm not actually claiming it's a mainstream. Maybe it will be at some point. So anyway, there is a function called pesant. It takes 2 numbers, integer and integer or something like that, and it gives you back optional usize. So it's just a multiplication. It's an alternative multiplication. It's called pesant algorithm. you probably don't know it, it's fine. So how would I test it, right? I would ask quick check to check this property called pesant is the same as multiplication, right? And the shape of this property will be a function which accepts two numbers and give me a Boolean back. And then I will define the property itself, right? It accepts two numbers and gives you Boolean back. And then the property itself, right? So when I invoke my pesant with these two numbers, right, it has to be the same as original Rust implementation of multiplication. Easy. So it is possible in Rust as well. That's my point. I guess that's the end of the talk. I don't really have any conclusion. I don't really want to say that writing property-based test is about quality. It doesn't actually guarantee any quality. It just gives, as any other like tests, it just gives you support, and I think property-based test gives you even more support. So no conclusion, just want to ask you to like go and do it yourself in your mainstream languages or like non-mainstream languages. Thank you.